So my name is Sagar Ekade. I represent Capstone project on speech emotional recognition using deep learning and ML. So first is this is our content: introduction, problem statement, data summary, dependency, analysis of data, augmentation, data augmentation, model, confusion matrix, loss of sort, challenges and conclusions. So next is introduction. So first, what is speech emotion recognition? So speech emotion recognition means to recognize the emotion who in front of you. Human can do it better than machine before AI and machine learning. So why it is so important? So now in new era, we see that we also use Alexa and Siri, and with that, okay Google, they use speech image recognition because now it is a big now it is booking your dinner table, and it is on its own without any disturbance. Disturbance means without any human help. They are talk like a human. What is the scope of speech emotion recognition? Nowadays we are developing a robot or other type of machine which work with us. So they want to know about our feeling. So in that situation, speech emotion recognition work better. So next is a problem statement. As human being, speech is the most among the most natural way to express our emotion. We depend too much on it. That we are recognized its importance in restoring other communication from like email and text messages. Emotion play an virtual role in communication, detection and analysis of the same uh, of vital importance in today's digital world and remote communication. This is our data summary, which we use a Reddit dataset. It contains 1,440 files. In data, we speech emotion include a claim, happy, angry, speech, fearful, and surprise, and expression. This is our data link. Kaggle. So next is dependency. It contains NumPy, Panda, Matplotlib, Vero, Librosa, Streamlit, TensorFlow, CPU. So next is analysis of data. So next is data part, which use in this part. It analysis of data. After analysis the data, you see that the male neutral and female neutral are audio are more than any other data. It is overfitted. We are reduce overfitting using some technique they are in mention. So next is male spectrum, which used for male to provide our model without sound information, similar to the human expression. So we see that our spectrum which show about the female happy. So after that, we plot a wave plot which contain a female fearful. So after that, we use female. After that, we use female happy track. Both female and male voice. We see that female have low pitch voice, while male have high pitch voice. Male use the full pitch range during speeches, while female vary the pitch range during the speech. So next is data augmentation. Why we do data augmentation in speech emotion recognition? Because our project is based on speech. So when someone speak, then ignorant is not going to silent every time. So we want our model very tough. So that's why we use a data augmentation. It contain noise, stretch, shift, and speech. Shift. Using this technique, we make our model very robust. In this process, we cannot change our data. We only create a new uh, polymerized data. So first, we take a normal audio that set after applying some technique like stretch and stretch and some other we will only mention in our here all other technique in our book. So we use only stretch. The audio stretching is process of changing the speed or duration of an audio signal without affecting its speech. So next is model. Our first model is K-NN, K nearest neighbor, is one of the simplest classification algorithm and one of the most used learning algorithm. Its purpose is to use a database in which the data point are separated. Uh, the data point are separated into several classes to predict the classification of a new sample point. Next is a decision tree. The goal of this algorithm is to create a model that predict the value of the target variable for which the decision tree uses the tree representation to solve the problem in which leaf node correspond to a class label and the inner node attribute are represented on the tree. So next is MLP. MLP classifier, which is used to categorize the given data into respect to group which are linearly separated. Male frequency, male frequency, chroma and male features are extracted from the speech signal, and signal are used to train the MLP classifier. Next is a GRU. GRU employ an update gate and a reset gate. Essentially, they are two vectors that determine what information should be sent to the output. They are unique in that they can be trained to return knowledge from a long time ago without being washed away by time, or to discard information that is unnecessary to the prediction. Next is LSTM, long short-term memory. Network are the type of RNN capable of learning order dependence in a sequence prediction problem. This is a behavior required in complex problem domains like machine translation, speech recognition, and more. Next is a CNN. CNN is a convolutional neural network. Is a type of artificial neural network used in image regression and processing that is specially designed to process pixel data. The speech emotion recognition is based on convolutional neural network algorithm, which use different module for the emotion recognition, and the classifier are used to differentiate emotion such as happiness, surprise, anger, neutral state, and sadness. So next is confusion matrix. We use the confusion matrix to compare the actual label to the predicted label to label to predict label, and we observe the female claim is too high. This is our loss accuracy plotter. Next is a loss accuracy plotter. In this loss accuracy, see that this loss plotter adopting the training and testing loss. Notice that the testing loss is more than training loss. The graphical below express the training and testing loss on all data set. According to the graph, as the number of epoch to the training model rises, both training and testing error decreases. Next is challenges. Large speech data set to handle. annotating an audio recording is challenging. Should we label a single word, sentence, or whole conversation? How many emotions should we define to recognize? It is not easy task to convert speech to emotion. And next is emotion are subject to people who interpret it differentially. It is hard to define the notation of emotions. Next is conclusion. Through this project, we show how we can leverage machine learning to obtain underlying emotion from speech audio data and some insight on the human expression of emotion through the voice. This system can employed in a variety of setup like call center for complaints, for marketing, or marketing, in voice-based virtual assistant, of chatbots in and etc. So code which are deployed in the GitHub repository. It was such an amazing and interesting project. We learn a lot from this. Thank you.